Aloha. This is a second video in the conceptual intro of the class here, but it deals with kinematics, solving equations that deal with when things move. And this is a strategery that I want you to always follow, and it's called the WISE method. So it obviously says when solving physics problems, be wise. All right, so what that means is follow a 4-step procedure. That means the first letter is obviously a W. And so that stands for what is happening. When you're reading a story problem, when you're interpreting something that's going on in a physics class, you gotta just categorize it into a what the heck is going on type of situation. The way you communicate to me that you are interpreting that what the heck is going on is by doing one of two, if not both, making a variable list and making a diagram. Okay, if it's anything to do with these kinematics, oftentimes variable lists are fine. Sometimes it is helpful to make a diagram if you're launching something up onto a roof, or if you're projecting something down off of a cliff, things along those lines. If you're hitting a target that's a little higher or lower, then you may wish to make a diagram for something like that. If it's anything to do with Newton's second law, the F equals ma, and you're summing forces on objects, then you will always make a diagram. All right, just get in the habit of using the chalk to make a diagram. Do it. Physics and art. I just don't know what they would call it. The I in WISE then stands for the identification of whatever equation you're going to use. Now, this kinematics section is going to have 5 of them, so the ability to identify the correct equation is a good skill to have. Now, what will help you identify the correct I is by looking at your variable list that you so diligently made in the W step. All right, that W is when you will be listing xi's, xf's, vi's, vt's, whatever, all those variables you're going to list. So you're going to have everything you know and everything you don't know. That will certainly help you identify what formula you're going to need. Right there with the identify is to isolate the variable you're looking for. So not only did you write the equation, next I want you to isolate whatever variable in that equation you're looking for. So that's when I say let the letters dance. Do the math with letters. Rearrange the equation. Let the letters dance to isolate whatever letter you need on one side of the equal sign. All right, let the letters dance. Do math with letters. Let the letters dance. Do math with letters, not numbers. Don't do math with numbers until the S step. The S also has 2 parts to it: substitute and solve. And you know, substitute means put something where something else used to be. And that this is where you will put numbers into the equation. Once you've rearranged everything, got it to the version of the formula you need, now put numbers where letters used to be. You substituted, then go ahead and solve it, which means use the magic box, push some buttons, do what you got to do to just do the math. So substitute and solve. Put numbers into the rearranged equation. Do the math all at once, okay? That's another skill I'm going to really harp on you. Your magic box is full of mojo. It can handle long, typed out calculations. Please do them all at once. It's very annoying when students baby step through the math. They push 10,000 buttons just to do one equation. It makes none sense. But that is a skill I will bang into you guys pretty hard, is doing the math all at once. All right. The E stands for the ability to look at a number and kind of tell if it sucks or not. That's the skill, which is a very difficult skill. Just because the magic box gives you a number don't mean it's the right number. You know that. So E stands for evaluate the answer. Magnitude, that just means, does it make sense? Is it big, way too big, way too small? A 5-ounce bird can't carry a 1-pound coconut, okay? Magnitude. Direction what is there direction associated with it? Where are we going? Are we falling up? Are we falling down? Are we going left, right? Does that mean we got to have a positive or negative sign? Units. Make sure you put letters next to numbers whenever you have an answer. Right? You give me an answer, all right, a number, that's great. That's a magnitude, but you're going to need units to give that number some meaning, okay? And does it make sense? Like I said, is that ish, right? Circle, highlight the answer, all right? Meaning make it easily identifiable for me to say, oh, this is that student's answer. That's what that means. And so an example of someone using this WISE method is, hey, let's say your mommy picks you up from soccer practice. So she's nice enough to slow down to let you get in. Once you get in, she floors it. She gets up to 30 meters per second in 3 seconds. What acceleration did she just experience? So that type of story is a very common one. This is obviously a very easy problem, but what I'm going to do is just show you the WISE method to do it. So what I did there with the W in red underlined is show you that variable list. The VF is 30, the VI is 0, okay, because you get in the minivan. She's allegedly nice enough to stop to let you in. She started out at a position of 0, XF. Now here's another thing, XF. I put a question mark there. I have no idea how far this person, your mommy, drove. I don't know. It's not given in the problem. So leave it as a question mark. And the way you distinguish something you don't know from something you're looking for is what I said in the previous video. Write the word goal next to whatever variable you are looking for, okay? So A is your goal. XF is simply something you don't know. You have no idea what that XF is. It's not given in the problem. It's not known. It's not asked for. I mean, it's just something we don't know. And the time is 3 seconds. So you see how I wrote VS, VIs, XIs, XS, As, and Ts. There are 6 of those. And that's what I want you to remember. Variable lists. When you make these for these kinematics questions, variable lists come in 6s, okay? 2 X's, 2 V's, an A, and a T. Sometimes the 2 V's are the same. The VF and the VI are the same if you're going at a constant velocity. In which case, that's great. Say it's an average velocity or something along those lines. You can set them equal to each other. But 6s are the minimum. Sometimes you're going to have 2 variable lists. So, you know, those 6 variables listed for, say, falling up, 6 variables for, say, falling down, maybe another 6 variables for an entire trip. So sometimes variable lists come in 12s. or even 18s, okay? But hey, that's why there's an A in AP, right? It's advanced. Okay, so here's the I. You identify the equation you need based on that variable list. You had xi's, x's, vi's, a's, and t's. X's were not even involved, so that guided me to here. You're solving for an acceleration. So you've identified and you've isolated the letter you're looking for, that A right there. So see how I went ahead and did the math with letters I identified and isolated. Then I put numbers in. Here's the substitution part. 30 over 3 equals A. Again, obviously that's easy. It's just 10 meters per second squared. Does it make sense? Yeah, okay. 30 divided by 3. That's an easy one. I'm just explaining to you the evaluate. Make sure there's letters next to that number. Meters per second squared. Okay. The next equation or question I'm going to do now. Let's say your mommy picks you up from that soccer practice, but that's way the heck in Bridgetown. Oh, she's got to go from there to a piano recital in Milford. She's got to go 36 miles. And in like 10 minutes is when the recital starts, but you're probably not going to. But anyway, if she can get there in 30 minutes flat, what's her speed in miles per hour? All right, so she's driving from one end of town to the other. So here is another example. The XF, 36 miles. XI, I just called 0. It wasn't mentioned, but you can assume if she's starting in Bridgetown, ending in Milford, if that's 36 miles, her initial position was 0. See how VF and VI are then shown to be an average V, calculator speed miles per hour, for that total distance and that total time. So those two come together to form that variable. The acceleration is not given. It's not asked for. It just wants to know her speed in miles per hour, and the time is 30. So that's given. This then is the goal. That's what you're looking for. All right. So if any conversions are needed to occur, I usually tell students to do it in the W step. Okay. If not, then you'll notice it hopefully in the evaluate step. But you guys all know 30 minutes is about a half hour. So if you need to make those conversions, do it in the W step. All right. Do it in your variable list. Make whatever conversions may be necessary. Okay. So there's the W. The I then is this equation. It just wants to know that average velocity. Xi is 0. I'm going to rearrange it, do math with letters. So identify, isolate. Okay, there's the identify, the isolate. This then is the substitute and solve, which you then evaluate. So 36 divided by a half, 72-ish miles per hour. Does that sound reasonable for your mommy in her minivan? And I don't know, it's probably a little slow is my guess, but 72 miles an hour. If you miss the conversion, you would end up with an answer of miles per minute. 72 divided by 60. Or I'm sorry, 72 divided by what, 30? What did I say? Good Lord, 30 minutes. That what I said? That doesn't sound right. See, I don't know. 36 miles divided by 30 minutes. Yeah, 36 divided by 30 minutes. Would have been 1.2 miles per minute. I don't know. You probably have never heard a speed given in miles per minute, so don't use that particular unit system. But anyway, that is the WISE method. All WISE use the WISE method, which means figure out what is happening, variable list and or diagrams, if not both. Identify and isolate the equation you're looking for, isolate the variable in it, substitute, put letters where numbers were, and evaluate to make sure it makes sense. Yay,